So yeah, my name's Edward Thomas. I'm a senior consultant working for MarkLogic here in London. And this presentation is going to be about architecture. So can I just ask, are there any architects in the room? Great, a few. People who work with architects, business analysts, developers, business people generally. Okay, so I think that's covered more or less everyone. So you should hopefully find something of interest. I noticed we're in the what's and what room and just nerded out a little bit on the poster at the back. And he's the guy who invented radar. And I think it's an interesting callback to the keynote this morning, that radar started out as these huge things on the south coast of England to protect London. And now, if you go and buy a Tesla, it's got a radar built inside it. So unrelated to today's talk, but I thought it was interesting. So if you saw the keynote this morning, you'll have heard about multimodal databases. A multimodal database is a database that can store triples, structured content, documents, geospatial data, text, binaries, and other data types all together in one place. And you get a single mechanism for querying, indexing, and updating that data. And that's what I really like. Coming from a developer background is you don't have to worry about maintaining consistency between multiple databases. You can write a single query over your entire data set and have that update and manage all with transactional compliance. So we've got different data types here. So we've got, let's see, where's the laser? We've got documents, and these documents can be very structured documents in JSON or XML, like this, with keys and values and lists inside them. They can be completely unstructured documents. They could be Word documents or text, or they can be semi-structured documents with perhaps a little bit of embedded semantic information, like an HTML document. You have relational data. This is tabular data with columns that have perhaps some semantic significance, though it's not encoded with the data. You have rows and tables. And then you have semantic data, which you may have heard described as triples, as RDF, or as just semantics. And this is relationships between entities. So here we're saying New York is in the United States. The Jerry is a type of cartoon mouse. And the Jen knows Mike. Without a multimodal approach, without a multimodal database, then dealing with all of these three data types involves the overhead of ETL. It involves federation of search and query and results, and a developer overhead building middleware to manage all of these processes. With MarkLogic, you avoid this. You get a single place where you look for all of your data and a single mechanism for update and query. But I think the best way to understand this is to look at a real-life case study. So I'm going to change topic a little bit and talk to you about Pearson. This is a project that I worked on last year. They've gone through a really transformational change as a business, going from multiple siloed databases into a multimodal approach with MarkLogic. I'm really excited to talk to you about it today because I think they're really exploiting the full capabilities of MarkLogic, and I think it's a really exciting direction that they're taking the business. So Pearson was founded in 1840. It was originally an engineering company. They were responsible for building the Blackwall Tunnel, which goes underneath the River Thames. It's about 6 or 7 miles east from here. They invested in a lot of different markets, including publishing and broadcasting. In the 1950s, they acquired the Financial Times and The Economist. Now Pearson describes itself as the world's learning company. It has 35,000 employees in 70 countries worldwide. They have a long history of working with teachers, learners, researchers, and thought leaders. And their products and services are used by students and teachers across the world. If you have kids in school in the UK or the US or at college, chances are they've been using Pearson products. Oh, sorry. So, coming back to multimodal. In the case of Pearson, they have a curriculum based on instructional content and assessments. One of the most important goals that they have is to deliver the right content to the right student at the right time. And what's very important to deliver this goal is that they can represent their content semantically. It's cheaper for them and more efficient for them to separate the semantic content concern from the user-facing experience. It's more costly to couple presentation and data than it is to go back and re-engineer the content creation processes. So what they have today looks like this. They've got meaning and content itself tied up in application code, in relational schemas, data domain models, and entity relationship diagrams. And some of these are so complex and so large that they can cover entire walls of conference rooms. And they have ETL scripts and stored procedures to move data and transition between different schemas, different models, and different applications. And the semantics and the meaning of their content is tied up in these three places. And it's actually more complicated than this. If you look at their data landscape, it's a little bit more like this. So at the top, you have the delivery channels. So this is how people actually interact with this content from Pearson. There's different applications in use in the UK, in the US higher education market, and in the US K-12. So that's sort of early education. They have different authoring and publishing tools, including things like Word and Excel. They have transformation tools to move between different publishing platforms. They have barriers between their data silos. These are not just physical barriers or barriers of distance. They're the fact that content in different regions and in different applications is described differently. There's no common vocabularies or ontology to allow different content to be reused easily in different locations. So you have a lot of transformation tools. You have content and using different content standards, JSON, SCOS, XHTML, and you have a huge number of different stores to be managed to actually contain this content. So Pearson has grown both organically and through mergers and acquisitions over the years. And this is reflected in this sort of diagram. They're a house of many brands, but last year unveiled a new unified brand. So they're tying all of their products together under this single unified Pearson brand. And there's been a multi-year effort to break down these silos and bring the content together. The silos expose inefficiencies that result in duplicate operational costs, duplicate development effort, and time-consuming, error-prone authoring and publishing processes. Plus, when content has to be transformed so much and go through so many different processes, it's very difficult to understand the analytics and the performance of this different content, because it's very difficult to get back from something that's viewed by a user in the delivery channel to the source asset in the databases. So the big picture, Pearson are trying to bridge the metadata and content. They're adopting a platform approach that includes metadata, content, and the relationships between them. So the relationships between the instructional narratives, questions, activities, teaching materials, and so on. And they think this is the best way to achieve their three core goals. These three goals are to allow users of their platforms to discover content more easily, to allow them to distribute content more efficiently, and to deliver the right content to the right student at the right time. It's very important for them that they can deliver business agility. The competitive landscape is growing more and more complex. There are new educational technology startups coming into the market. Some of the established technology companies, the large technology companies, are starting to move into this domain. And it's really important that Pearson have a very narrow focus and that they can deliver on this very well. And that focus is on education. So they made a choice of platform. They want to move to a combined document and triple store. So they adopted MarkLogic. It offers all of the benefits of a traditional relational or transactional database, a document database, and a triple store. Plus the fact that you can have documents that contain triples. Triples can annotate documents, and you can embed documents into your semantic graph. It gives you extremely fast data integration by using semantics to glue pieces of information together, and it gives you a great model for reference data, metadata, and provenance. I'm not sure if anyone was in a talk this morning about the provenance ontology, but that's been a huge game changer for some of our clients. It allows you to run incredibly powerful queries over all of this data and do it with a single query mechanism, and again, with fully transactional consistency. You can use ontologies and controlled vocabularies combined with the semantic capabilities to drive data integration and to make it easier to run queries across content from different sources. This all uses industry standard models such as SCOS, OWL, Dublin Core, Ferber, schema.org, and the provenance ontology that I just mentioned. It all runs at massive speed and scale, gives you the simplicity of a single unified platform for scaling out, for doing high availability, and you get all of the enterprise features operating consistently over all of this data: security, high availability, and ACID compliance. So, the way that architecture works at Pearson is like this. They start off with business direction planning. That then feeds into enterprise architecture, which feeds the application architecture, which drives the solution architecture. They define initiatives at the portfolio level, and the product strategy team meets very early on with enterprise architecture to validate the feasibility of an idea. Once they've determined the feasibility and identified that there's a business case, they identify the teams that will be responsible for delivering the solution and collaborate with the solution architects within domains to build out the platform or the solution. So, they identified a need to move from a single learner model to a multi-learner model. Now, Pearson managed the transition from print to digital a few years ago. They targeted having immersive, engaging, human-driven experiences that transcend different devices. So you have an omni-channel digital textbook experience. This can deliver rich interactives, multimedia, and instructional narrative content across different device channels. Now they're looking at ways to build upon that strategy by delivering immersive content that suits different styles of learning. They're calling this the multi-learner model. And whereas in the single learner model, you have these great experiences, but every student or every learner has the same experience. They go from A to B, and they may skip forward if they feel they can, or go back and reuse content, but they're effectively on a single journey. With a multi-learner model, the model itself can adapt to the student's needs. It can offer different information, and depending on how a user wants to learn or how a user is learning, it can take them on different routes. They can delve more deeply into certain pieces of information, and it can react to a student's performance in tests to offer content personalized to that student. So, there are two primary persona groups that we're going to focus on: editorial teams and instructors or learners. I'm going to start with Meredith. Meredith's an editor who wants to discover content. So she has been tasked with partnering with an author to deliver a digital psychology course designed to introduce students to psychology. She believes that the best way of delivering this course and the best outcomes for her students will be by adopting rich media and simulations from the library of assets that Pearson already possesses. But she doesn't know how best to reach into this rich repository of assets. She doesn't know how to find them within this landscape of databases and different systems that Pearson has. So the problem statement is, how can Pearson help Meredith in building this rich curriculum? And the solution here is to take a multi-model approach that makes discovery of metadata-enriched content possible through a simplified architecture, by presenting all of the content along with its metadata, by making it searchable and allowing Meredith to navigate through this and discover the assets and resources that she needs to deliver this curriculum. Our second persona is Abigail. She's studying psychology, and she found some of the theoretical chapters at the beginning of the course pretty easy. She managed to get through those with no problems, but finding that the biological psychology chapters much more challenging. She's been taking self-study quizzes as she goes, but she's not managed to succeed and pass through these sections. So she doesn't know what to do to get past this hurdle. So how can we help her? The solution here is adaptive, personalized learning. With the traditional approach, the single-channel approach, Abigail would be forced to reread material she's already looked at or go outside of the Pearson ecosystem to try and find more data. There may be some bibliographic references that she can find that can point her towards a library, but these could be very difficult or costly to find. With the adaptive approach, the system and the platform can evaluate how Abigail has performed in these quizzes, in these tests, can identify the exact parts of the curriculum that are causing her more difficulty, and reach out and find more assets and more resources to help her achieve her goals. So now we've looked at the personas, let's have a look at the data that's required to support the use cases. The data is managed between three loosely coupled but very coherent domains. And those are content, context, and learn. Now, content is what you'd find if you opened up a book or went on YouTube and watched an instructional video. It's the assets that are consumed by the users when they're going through the learning process. It also is supported by descriptive metadata. This metadata can tell the user or tells the system what type of content it is, who created the content, when it was created, and perhaps any particular entities inside the content which are specified in a controlled vocabulary. Context is like a table of contents. You can think of it like a table of contents in a book or a menu on a DVD. It puts the content into context. It allows you to navigate through the context, find more specific content, or go to more advanced study. And the learning objectives, the learn model, are the actual pedagogical objectives of the system. These are like examination questions. What are the nervous system neurons and nerves, and how do they relate to one another? So you've got information here that's incredibly rich in semantics. You've got something like a Scoss taxonomy over here in the context. You've got entities and descriptive metadata in the content model, and you have entities and relationships and objectives, prerequisites in the learn model. So we want to be able to query at the intersection of these three models to determine what content will be useful to support Meredith in building a course and what will help Abigail meet her learning objectives. So there are these three domains that we need to model: content, context, and learn. And we'll look at them in a little bit more detail here. So on the left here, this is the fragment of something you might find in the content model. There's a very simplified part of an ontology at the top, where you have creative work and you have two more specific items, narrative work and audio object. These come from schema.org, so it's an open standard ontology. And then there's relationships between this concept of narrative work and an example of narrative work, and from an audio object and an example of an audio object. So this could be a text file, a PDF, or an HTML file that's stored in MarkLogic. And here we have a binary digital audio file. In the context model, we have, again, something like a table of contents. We've got chapter 2, the biological perspective, and then a has-part relationship to the biological perspective, and then navigation information. How to go, what's next? Well, it's neurons and nerves, building the network. And then in the learn model, you've got a top-level objectives framework from a psychology textbook, which has a top goal describing a question. What are the nervous systems, neurons and nerves, and how do they relate to one another? And what's missing from this content is the incredible richness of the links between them. What sits at this intersection? So you have common vocabularies, common ontologies that allow these different models to be linked and to be navigated together. And what you get to is this: mixed model queries across multi-model data. So here, our query is to find all content models that instruct what are the nervous system neurons and nerves and how do they relate to one another, that have a narrative work as part of their content, and that contains this text tree, brain-computer interfaces. So this query looks at two different types of data. We're looking in the RDF store to try and find relationships between entities. We're looking in a document store to do a full text search over documents, looking for the string brain-computer interfaces. And what we can do with MarkLogic is to perform a query across these two data sets with a single join that will find these narrative works. I'd like to also mention here now, in MarkLogic 9, there are new tools, for example, the Optic API, that make this more natural and easier to do with even more complex joins and different data sources. The result of this will be a document from the JSON document store. You could use the context model to navigate up and show the context of this data. And also, you can imagine that, for example, in Meredith's case, she might want to look at multiple results from a query such as this, and then navigate around those results to try and find other interesting content resources that could help at a particular point in the curriculum. So you can use what's in this RDF graph, what might match the full text query on their own to relax the query and offer additional suggestions of related content that she could find interesting. You could imagine the same approach being applied to Abigail, where she can broaden her, to go out to a broader view of a topic and get more information that could help her achieve her objectives. If you work in any number of fields, you might find applicable use cases in your domain. For example, if you work in finance and you want to put together packages of documents for your clients, for example, around a mortgage deal or something similar, you could take a similar approach. I have a background in legal publishing, and the same approach would work well there. If someone's looking for a piece of law or a treatise, you can offer information around that domain by adopting an approach like this. The second query we have here, we're looking for all assessment instruments that assess what are the nervous system neurons and nerves and how do they relate to one another, that has a part MQA assessment item query. Now here, we're looking mostly into the RDF store. So we're looking for relationships between an assessment item, an assessment instrument, and the learning objective. But then we want to take the results of this query, find the resources with that URI in our document store. We can then transform those along with the other results from the query to produce a customized assessment instrument. So here we're combining dynamically different assessment items to produce an assessment instrument that's specifically targeting a particular user's needs. So this is the target ecosystem for 2017 at Pearson. I think you'll find this is a lot simpler than the diagram we had earlier. Jen Shorten, in a previous presentation, said that at MarkLogic we get paid for building diagrams with fewer boxes in them. And I think at Pearson they've taken that approach and run with it. So over here we have authoring tools that generate data to be stored into MarkLogic. There are APIs exposed from the MarkLogic database that can then be used by learners through content access web applications, iOS applications, Android applications, and so on. And UX design teams can build on top of that. Pearson are using PoolParty to manage ontologies and reference data, control vocabularies, which are stored directly into MarkLogic. And they're using Apogee to federate and expose these APIs across their business and to partner organizations. So they recently announced in a press release a partnership with IBM that introduces cognitive tutoring capabilities into the Revel digital experience. This is using IBM Watson, and it means that instructors are being provided with insights from Watson while students are able to experience the tutoring capabilities. Semantic content and metadata authored using the content platform is underpinned by MarkLogic and used to train Watson. And they're piloting this capability this year. And what's really interesting here is the agility with which this sort of partnership was made possible by taking the multi-model approach. By having a single source for the content and metadata, they were able to expose the content and metadata that was required by Watson very easily, that was enables them to power this kind of partnership. So as the platform matures and the models overlap more, they'll be supporting additional models. So they're also going to be looking at a student model. This is all about recording information about individual students' needs, progresses, and specific ways of learning. They're going to be adding an analytics model. This is about closing the loop so that they can feed information back into the editorial team. They can understand what students are having difficulties with what areas of the curriculum, focus their editorial effort on targeted assets to support those students at that point. So to recap, we've got a transition strategy from the single learner model to the multi-learner model. They've got a multi-model platform approach with content and metadata, which is being used to overcome the existing silos and affect this transformation. And they're implementing use cases based on their main goals. To discover content more easily, to distribute content more efficiently, and to reach the right learner with the right content at the right time. I'd like to now thank hugely Amie Brown at Pearson and Frank Rubino from MarkLogic, who delivered this presentation at MarkLogic World in Chicago, and ask if you have any questions. Yes?
So, forgive me if I missed the detail, but have you built in effect an indexing system on top of existing content stores? Have you migrated all the content into MarkLogic databases?
No, the content is being migrated into the databases. So it's not a common index or a federated search. It's about bringing all the content together. And that's an ongoing process. It's not a single.
So building a lot of formats in that data.
Yes.
Does your migration involve rebuilding the data, translating it, or do you just take it as is? So, to recap the question, you're moving all the data into huge MarkLogic databases.
Yes.
And what I was wondering was, it'll be in many formats because it's in all these stores.
Yeah.
Are you transforming it on the way across, or do you just deal with it with all the different formats in MarkLogic?
So the assets themselves are being loaded into MarkLogic as is. I think this is not a part of the project that I was involved in, but I think what will happen is some of the metadata around the content is being transformed into the organizational ontology that's being used across Pearson. So there's some alignment of the metadata. The content is also going, there's some plans to enrich the content and to, again, add some more metadata using the same formats.
My understanding is they're generating triples.
Yes.
You don't necessarily have to actually do triples, but the assets themselves are stored, as you said, the chapters.
Yes, well, I was just wondering where that complexity is handled, because you're talking about, you had the classic diagram where there's application developers can now treat all the data as if it's uniform, but of course they can't, because all the content is still in its original form. So have they written translation layers? Or?
No, they're linked together by the ontology. So we use
But that only gives you metadata, not content.
because you can query together, you can query the
But if I need to process the content, which is what those front-end applications will do, then I might have 6 different video formats.
we are transforming on write. On read. So when they will
Okay, so it slowly will migrate to a standard format.
I don't know that it necessarily needs to. I mean, if it's being transformed on the way out, it's just, you don't need to necessarily then write that back into the database. You can just store it as is. It's been a while
Okay.
since I've been involved in the project, so I haven't changed that since.
I just wondered, how big is the MarkLogic database? Or databases, I guess you might have many.
I'm not sure how big it is now. Probably bigger than it was when I was.
Yeah, big
I was
in terms
involved.
of how
Just storage, you know. Is it a petabyte? Is it a couple of hundred terabytes? Is it
No, it's,
gigabytes?
remember, this stuff, it's all text, right? It's not very big.
Well, it's rich media, isn't it? So,
Yeah, but already after, it's just stored recently. It's a few megabytes. It's envisioned that there will be millions of triples in the data store eventually. But,
Yeah, I think billions. Yeah.
yeah, but it's not a small installation, but it's nowhere near one of our larger.
okay, thanks.
Sorry, I don't have that exact.
You've changed the architecture display from the initial slide to this one.
Yes.
But how did you make sure that you actually broke silos rather than just creating a new one?
So I think the key technique for breaking down the silos is the organization has to commit to this. So they have to, make sure that people don't go back to form and start going back to the old data sources. So this isn't treated as another silo. This is the single source of the learning objectives, contextual and content metadata, as well as the assets themselves. So it's about ensuring that as things go forward, they comply with the newer architecture. It's also important that tools like Pool Party, which allow controlled vocabularies to be created and shared across the business. It's important that if one part of the organization creates a learning objective about a particular topic, that another part of the organization knows what a learning objective is, and that they use the same name for a learning objective, and that they use the same name for the topic that learning objective covers. And if they do that, then they can go into the content store, and they can go to MarkLogic and say, give me the learning objectives that talk about neurons. And if everyone uses the same terms for learning objectives, the same URI in a semantic sense, then that's effectively is how those barriers are broken down. If you keep having different parts of the organization having different concepts of what a learning objective is, then of course you can still end up with a fragmented landscape. So it's important for the organization to follow through and ensure governance on top of these things. But tools like Pool Party make it really easy to share and create these models and to federate them across your organization. Yes?
I think it's a follow-up on that. So are these guys using Pool Party?
Yeah, so the question was, are they using... Yeah.
Sorry, to enrich the data sources or the content with metadata, which is semantic triples and so forth, are they using Pool Party to do that part manually? Are they kind of saying, right, we've got a controlled vocabulary here, which contains these 300 controlled words that we're allowed to use to enrich our metadata? How are they doing that manually using something like Pool Party to say, let's take control of this content appears to be about these three concepts, so we'll apply these three and we'll use Pool Party to do that.
So automated content extraction based on... I'm not sure if they are.
I think I don't know that they're using the enemy extraction, but as I understood it, when we started the project, they were using it for ontology management.
Yeah, I mean, it's a capability Pool Party has, but I'm not sure if it's been deployed at this point.
They have so much going on with semantics at Pearson, and we're just really one piece of that.
Yeah.
There's lots of stuff going on, and everybody has visibility. They're doing some really interesting stuff.
Okay, I think the lure of cake and coffee is too strong. But, thank you very much for attending and for some great questions.
Yeah, and it's up on the third floor in Riverside.